Welcome, my dear students, to the class of 11th English Medium. The subject is Statistics, Chapter 8, Function, brought to you by Vitan Sir. We have already studied about what is a function, the notations in which it can be expressed, its domain, codomain, and range, and various types of a function. Now in this tutorial, we are going to discuss about equality of a function and real function. Let's start with the first one, that is equality of a function or equal functions. What is an equal function? If there are two functions f and g, let's name them f and g, then to decide whether these two functions are equal or not, whether f and g are same or not, we have to follow two conditions. Now the first condition here, that domain for both the functions should be same. When I say domain, it means that the values of the variable belongs to a certain set, and that particular set, let's name it set A. Then the fourth function f and for function g, that set A should be common. That means f should also be a function from set A and g should also be a function from the same set A. That's the first condition. The second condition which we have here is that for each value of the domain, the images of f and g must be same. That means when I take each and every value of the domain and put it in the functions f and g, the answers which I get, the images which I get must be same. Now that means that all the answers which we get using the functions, for both the functions the answers should be same. So the first condition, that the domain should be same, and the second condition, that the answers, the images which we get by using the function should be same. So these conditions are satisfied, then we can say that functions f and g are equal. So if I represent this in notations, it would be if f is a function from set A to B and g is a function from set A to C, where x belongs to set A, then fx is equal to gx. Therefore f is equal to g. Now let me explain these notations in detail here. The first condition is that domain should be equal. So let's see here, f is a function from A and g is also a function from A. That means the domain in both the functions are same. It doesn't matter whether codomain is same or not. That is not part of our notations or equation here. We don't need to let codomains be equal. They may be equal, they may not be same, does not matter. What matters is that the domain must be equal. X belongs to A, that means the variable x belongs to both these equal domains, and fx and gx are the images, the answers. That's the second condition here. So if fx is equal to gx, that means that whenever I take a value of x and put it into fx and gx simultaneously, I should get the same answer. So first condition, domain should be equal. Second condition, range, the images should be equal. Then functions will also be equal. Let's take an illustration to understand this. Illustration 7. If f is a function from n to n, that is natural numbers, and fx is x square, g is a function from z deducting the 0 to n, that is it's a whole number without 0 to natural number, gx is x square, can we say that f and g are equal functions? Now what we need to do first here is to decide whether the domains are equal or not. What do you think? Looking at the domains, the domain for function A, that is the first function, is capital N, whereas the domain for the second function is z subtracting the 0 element. So naturally you can see that the first domain is a natural number, the second domain is a whole number without 0. the domains are not equal. The first condition is not satisfied. So if even the first condition is not satisfied, we don't need to check the second condition. We can directly say that these two functions are not equal, because even if the first condition is not satisfied, we can declare it that it's not an equal function. We don't need to then check for the second condition. Illustration 8. If f is a function from set A to set B and A is 1 and 3, B is 1, 4, 9, 16, fx is x square, and g is a function from set A to B, gx is 4x minus 3, we have to check the equality of functions. As you can see here, f is a set from function from A to B, g is also a function from A to B. We don't care about the codomains, but look at the domain here. The domains for f is A and domain for g is also A. That means domains of both the functions is equal. So that satisfies our first condition. The second condition, the range, the images, that we will have to calculate manually. So first we have the domain values 1 and 3. We will take x is equal to 1, put it into our first equation fx x square, that is 1 square 1. Second equation 4x minus 3, so 4 times 1, that is 4, minus 3 1. So the first value for both the functions is 1. We will move forward towards the second value, that is 3. So putting 3 into equation, 3 square 9, and for g it is 4 times 3, 12 minus 3 9. So as you can see here, both the domain values have equal answers for both the functions. So second condition is also satisfied, that is images for both the functions are also same. Therefore we can say that the functions f and g are equal functions. Let us take one more illustration here. If f is a function from set A to B, fx is 1 minus 4x, and g is a function from set A to C, gx is 6x plus 1, and the value of set A, which is common in both the functions here, is 0, 1, 2. Are the f and g functions equal? Let's see. First condition is actually satisfied, that f belongs to A and g also belongs to A. That is, domain for both the functions are equal. So first condition is naturally satisfied here. Then we will move forward towards the next condition, that is whether the images, the answers are equal or not. For that we have to put these values into these equations and check whether we get the same answer or not. We will start with x as 0. I will put 0 in both the equations here. 1 minus 4 times 0 is 1 minus 0, 1. Whereas when I put 0 here, 6 times 0 is 0 plus 1, 1. Okay, so first answer is equal. Good. We will check the second one. The rule is all the three values must have same answers. Okay, not just 1 or 2. All the values must have same answer. So even if a one value does not have the equal answers in both the equations, we can't say that they are equal functions. Let's check x is equal to 1. f1 is 1 minus 4 times 1, that is negative 3. g1 is 6 times 1 plus 1, that is 7. As you can see here, for the function f we get negative 3. For the function g we get 7. And that clearly means that the answers are not matching. And therefore, we can't say that the functions are equal, or we can say that the functions f and g are not equal functions. I hope you guys have understood this concept properly, because now we are starting with the next concept, that is the concept of a real function. It's a pretty simple method, pretty simple equation, something which every one of you can do easily. Let's understand what is the meaning here. If f is a function from set A to B, where A is a subset of real numbers, that is A belongs to real number, then f is called function of a real variable. And if range of f is also defined on real set R, then f is called a real function. Now you might be wondering that what are these real numbers, as there is a chance that you have forgotten the meaning of the set of real numbers. So let me explain that first. You need to remember that R, that is the set of real numbers, mean all the real numbers, whether they are positive numbers, negative numbers, whole numbers or fractions, all of these numbers are part of a set of real numbers, that is set R. So whenever our domain is a part of these real numbers and our answers, the images we get by taking the values of a and putting it into our function, when those values are also a part of set R, that is a set of real numbers, we can call our equation a real function. That means technically all the sets of values in our syllabus will belong to real numbers, because we are studying very basics of statistics and we are not going to study mathematics in depth. We are only going to get a set of real numbers. Okay, we are not going to get other kind of numbers in our calculations. A function for which domain and codomain are defined on real set R or any subset of it is called a real function. So this last definition is an official definition of a real function. Remember this definition, but don't forget to understand this concept properly. What better thing there could be to understand apart from the illustrations? We are going to start with illustration 10. What we are going to get under this kind of concept? We have a function here, x cube plus 1 upon x square minus 2x plus 1, where x belongs to z minus 1, that is it is a z but not 1. We have to find f negative 2, f negative 1 and f 0. These are the three values which we want to calculate. That just means that in the place of x I am going to put negative 2. That means in the place of these x's I am going to put negative 2, get the answer, put negative 1, get the answer, and put 0 and get the answer. Starting with putting negative 2 there. So negative 2 cube plus 1 upon negative 2 square minus negative 2 into bracket negative 2 plus 1. So negative 2 cube is negative 8 plus 1, negative 2 square is 4, negative 2 into negative 2 is plus 4 plus 1. So that would be negative 7 divided by 9. This is the answer for the first function. Second function, that is f negative 1. So just take negative 1 and put it at all the places where x is there. So negative 1 cube plus 1 upon negative 1 square minus 2 into negative 1 plus 1. Just solve this. Negative 1 cube is negative 1 plus 1 upon positive 1 minus positive 2 plus 1. You get negative 1 plus 1, 0 upon 4. Naturally the answer is 0. Moving on towards the last one, that is taking 0 and putting it in the equation here. So 0 cube is 0, 0 square is 0, 2 0 0. So we are left with positive 1s, 1 upon 1. The answer is 1. So using the given equation and by substituting the equation with the asked values, that is negative 2, negative 1 and 0, we get our answers. The concept of real function is going to be this simple. We are not going to face any kind of problems with that. We have fx is equal to x cube plus 3 raised to x minus x square minus 2 raised to x. Then we have to find f3 minus 6 times f2. What we need to do here is that first of all substitute these x's with 3, get the answer, then substitute it with 2, get the answer, and then solve this equation by putting those two answers in it. We will start by substituting f3, that is wherever x's are there I am going to put 3. So x cube will be converted into 3 cube, 3 raised to x will be 3 cube, x square will be 3 square, and 2 raised to x will be 2 raised to 3. Just simplify this. 3 cube is 27, 27, 9 and 8. When you simplify this you get 37. So f3 is 37. Similarly f2 will be 2 cube, 3 raised to 2, 2 square, 2 raised to 2. 2 raised to 3 is 8, 9, 4, 4, and simplification is 9. Now what we need here is f3 minus 6 times f2. So f3 is 37, whereas 6 times 9. 9 6 are 54. So 37 minus 54 is negative 17. So these are the kind of questions which we might face when we are solving the concept of real functions. It is very easy, very simple, something which actually you have been doing since secondary standards. Illustration 12. If fx is x bracket 2x minus 7, where x belongs to R and fx is 15, we have to find the value of x. That means the equation is given, the function is fx is equal to x into 2x plus 7, and we also have the answer here, that is 15. What we need to do here is find the value of x for which we will get 15. So it's simple, we are going to substitute fx for 15. So we will get an equation like 15 is equal to x into 2x minus 7. Open the brackets, so x will be multiplied with 2x and x will be multiplied with 7. So 15 into is equal to 2x square minus 7x. What I am going to do next is I am just going to change the sides. 15 will be taken on the right side, so 2x square minus 7x minus 15, which we can write for our convenience as 2x square minus 7x minus 15 is equal to 0. It doesn't make much of a difference. Next, we have to factorize them. Now, what is the system of factorization is that you take the factors for the multiplication of first and the last values, that is 15 to the 30. So you need to factorize that 30 value to get the value 7 in them. For example, the factors of 30 are 1 and 30, 2 and 15, 3 and 10, okay, 5 and 6. So in there somewhere you need to get that answer 7. For example, the factor 1 and 30, the total is 31, the difference is 29. You are not getting 7 there. Next factor 2 and 15. 15 plus 2 is 17, 15 minus 2 is 13. So similarly you are not getting any answer there. Next factor 3 and 10. When you add them up, you are getting 13. But when you find the difference of 3 and 10, you are getting 7. So naturally, the 7 factor, that is 3 and 10, you will divide your 7 into 3 and 10s. So it will be 2x square minus 10x. Now you are supposed to only get 7 here. So negative 10x, we will add up 3 in there. So 10 is negative, 3 is positive, you will get a negative 7. And we will continue with negative 15. So this 7x will be divided into negative 10 and positive 3. Next, we are going to draw two lines here. The first part will be 2x square minus 10x and the common will be 2x. The second part is 3x minus 15 where the common value will be 3. So when we take out these common values, we are left with x minus 5 in the brackets, and the simplifying this becomes 2x plus 3 and x minus 5. Now both of these values, the multiplication is 0, so it could be either 2x plus 3 is equal to 0 or x minus 5 is equal to 0. So when we change the sides of the values apart from x, we get x is equal to negative 3 upon 2 or x is equal to 5. So that's the end of our answer. We are not going to move any further than this. If we put negative 3 upon 2 into our equation, we get 15 answer, or if we put x is equal to 5 into our equation, we will get the answer 15. Actually, we don't need to verify this right now, but if you guys want, you can do it on your own and check whether we are getting the answer 15 or not by putting these values into this equation. Dear students, illustration 13, which is also the last illustration of the chapter, and that means our chapter will end after this. It was a pretty simple and pretty small chapter. Just understand the concept of functions properly. In case of any doubts, you can just watch the tutorial, so you can call me up anytime you want. Illustration 13, if fx is x square minus 4x plus 8. Now this is the relationship function given already. Then for which value of x is f2x is equal to 2 times fx. What they have given us here is that we have to prove the value of x for which this equation stands true. So rather than finding the value of x, what I am going to do is I am going to convert this equation into f2x and 2 times fx first, and then I will compare them. So fx is x square minus 4x plus 8, and if I am substituting x with 2x, then it will be 2x square minus 4 times 2x plus 8. So simplification is 4x square minus 4 to the 8x plus 8. Similarly, I am taking 2 times fx. Now fx is x square minus 4x plus 8. I am just going to multiply it with 2 here. So it will be 2x square plus 4 to the 8x plus 8 to the 16. Next, I have to check whether these equations are equal or not, and because they have already told us that they are equal, I have to find the value of x. So I am going to write f2x is equal to 2 times fx and put these values here. So 4x square minus 8x plus 8 is equal to 2x square minus 8x plus 16. In the next step, I am going to shift all these three values on the opposite side, and all these three values will change its sign in the opposite direction. So 2x square will become negative 2x square, negative 8x will become positive 8x, and positive 16 will become negative 16. 4x square minus 2x square is 2x square, 8x and 8x will be cancelled, and plus 8 minus 16 will be negative 8. I am going to divide 2 from both the sides, so I will be left with x square minus 4. Change the side of 4, it becomes positive 4. X square is equal to 4, so when I root both the sides, I get x is equal to 2, but the thing is, it could be positive 2 or it could be negative 2. That means whether I take x is equal to positive 2 or whether I take x is equal to negative 2, I will get the same result, that is f2x will be is equal to 2 times fx. With this, our chapter number 8, the functions, ends. Thank you very much for watching this tutorial, this chapter. If you are new to the channel, please subscribe, and if you liked my explanation, please give me a big thumbs up. You can give your feedback in the below comment section and share this video with your friends if they are not understanding this chapter properly. Do watch my past videos. In case of any problems, you can contact me always. Thank you very much and see you for the next chapter. Welcome students to Vitan's Unacount Academy. That's better way to success for you. I am Vitan Vora and I teach accountancy, statistics and social science. You can contact me on my cell number 919426310184. Please give a sub to my channel and also check out my other video playlist which you can see on the screen. Thank you and I will see you in the next video.